So I'm conscious this is the last session of the day, so I will try to rattle through it all, and then questions at the end, hopefully. What I'd like to do is just give a kind of quick overview of options for scaling your Drupal site, followed by a discussion on kind of how we did so using Amazon Web Services technologies in particular. And then a bit about kind of things that will make your life easier when you do have a sort of complicated setup with multiple servers and so forth. And yeah, that should be it. So here we go. Almost all of the information I'm going to talk about here we sort of gleaned from creating this website. It's the Qatar Digital Library website, and please do go and have a look at it online. It features hundreds of thousands of historical source documents provided by the British Library, who have a team of people, archivists, scanning this stuff and uploading it to sort of backend systems. So you see under the sort of search results page, explore the archive, we're currently on about 250,000 pages. Because all of these are bilingual in English and Arabic, then you know, we're over 500,000 pages at the moment. Each of these pages features an extremely high resolution image. So you can see here that I've zoomed right in, it's looking at a tiny portion of the margin of one of the Arabic words there. So we've got a large amount of image data. We also have a large amount of text content as well, so there's sort of archival notes handwritten by the archivist, but there's also the OCR for typewritten documents where the data has been extracted sort of automatically, and that includes positional information. So here's an alternative view. If you click on Apply Page Layout, it will show you the OCR information as it would appear on the page itself, as well as the raw text. So in short, we've got several 100,000 pages. This is due to grow to several million pages in the next couple of years as the British Library carries on churning through their kilometres of shelving that they've got. We're looking at tens of terabytes of data, and then we've got a sort of an exacting client. They wanted to make sure that the system will be able to cope with any peaks in traffic, spikes in traffic, and also to be highly resilient, so that if there were any server or network outages, the system would stand a very good chance of being able to carry on functioning. So that's what we've created. To step right back, what is Drupal? What are we trying to scale here? So just in general, I'm sure you're aware, you've got a web server, Apache, could be Nginx, but anyway, it's a HTTP server, talking to PHP code, that then queries the content database that stores all of the content created by administrators, users, also Drupal configuration, and also assets stored on the file system. So essentially, these are the main components we've got on each server in its blue box. So let's scale it. There's two methods of scaling. One is grandly called vertical scaling, that basically just means get a bigger box. That's not what I'm going to talk about. I'm going to talk about this, horizontal scaling, which basically means get more boxes. So you have more machines able to handle more load. However, that's not a good idea. We have problems here, mainly due to replication and synchronization. So you can't just get one Drupal machine and go, okay, I've got a website on it, let's fire up 10 more, because things are going to start to get out of sync. If you've got a content editor or a user adding a comment or anything like that, you've got multiple databases, what are you going to do about it? It all gets a bit tricky. So an easier way to deal with it is to centralize that content. So to have a cluster of web application servers, the Drupal servers, but they all talk to a single content store. You've only got one source of truth as to what the information is that you want to display. You can also apply exactly the same idea to the assets on the file system. So it is possible to have a setup like this, but in that case, whenever files are created on any one server, you have to have another mechanism that will replicate and synchronize them. And this is perfectly possible using things like rsync. In our case, so as I said, we've got tens of terabytes of data, and so if you've got 5, 10, 20 front-end servers, if you're trying to replicate terabytes across that, then if nothing else, your storage cost will start to become astronomical. So this is the setup we aim for: is centralize the file system assets and the database assets onto separate environments and have all the front-end servers talk to it. This, however, it meets the requirements for throughput and scalability. You can serve an awful lot of data like this, but it doesn't meet any requirements for resilience. So essentially, to make the system resilient, you need to avoid any single point of failure. And in a way, up here, we've already got that. You can knock out one of these, and the other three will carry on serving. But what we do need to do is replicate the database and replicate the file system to make sure that, again, if any one server that's storing those goes down, the system will keep on running. So essentially, this is what we're aiming for. This is our target architecture of a scalable Drupal system. And already you can see we're looking at several machines instead of one, but they're all acting kind of in concert to be able to provide the twin advantages of throughput and resilience. So, how do we do it? First of all, a few three-letter acronyms that I'll be bandying about. Amazon Web Services has sort of grown to become they provide a huge range of products, but essentially there's some key ones that you're likely to come across anytime you're using it to provision a hosted website such as Drupal. First one is EC2. This is effectively means a virtual server. So if you have an EC2 instance, it is a virtual server running on their infrastructure, and you can, similar to sort of the bagel boxes they were talking about in the last talk, you can power them up, power them down, and so on. The next thing is relational database service. This is effectively a way for Amazon to host your database. So you could start up an EC2 server, install MySQL on it, and run it in exactly the same way as you would on any other physical server or local VM. But they also provide their own hosted database service, and this comes with a few advantages that I'll talk about in a second. And then finally, probably the most comprehensible acronym, ELB, it's a load balancer. It allows you to bounce requests between a cluster of machines, and also to do useful things like monitor their health to make sure that requests only go to machines that are actively available. So, what does this mean? This means that our target architecture on Amazon ends up as a cluster of EC2 servers, each one hosting an instance of Drupal, their web application servers. Equally, some other EC2 servers that will store our file system assets. And then here, we've got the relational database service here to store the data. In our case, we sort of use the pretty much Drupal default of MySQL. So in terms of, back here, you see we want to make sure that this stuff is replicated, and this is one reason, very good reason, to use RDS instead of your own hand-rolled MySQL setup, because they make it incredibly easy to provide that redundancy and that resilience. And literally, when you set up an RDS instance, you can say, okay, select this for multi-AZ deployment. I'll define what an AZ is soon. But effectively, what that means is it will fire up a completely new instance of your database, and that will synchronize the data between your master and the replica. So you end up with all Drupal requests going to the master database, but just by ticking that one option, they have a replica database. And if for any reason this fails, they will Amazon will automatically switch the IP record entry over to the replica, promote that to become a MySQL master, and effectively all requests to the database, there'll be absolutely no or extremely minimal loss of service as it switches from the master to the replica, and then equally it will come back again. So again, this is a sort of huge saving of time and stress, just to be able to rely on that. As far as the file system goes, Amazon provide various things that help you provision storage online. So they have something called elastic block storage, EBS, and this is like a file system mount. It's like a virtual hard disk, so you can attach these to your servers and add effectively disk capacity to store things. However, this is generally very easy if you're dealing with small amount of data. They have a limitation that there's the maximum size of one volume is 1 terabyte, so you can't simply just say, I want 50 terabytes of storage, just manage it in the same way you can actually with the RDS, where you can say, I want 50 terabytes of database storage, and they can probably do it for you. So in this, we use a third-party piece of software, open source software called GlusterFS, and this allows you to create, it's effectively a bit like RAID, but at the computer level. So you can combine multiple different storage systems in multiple different ways. The way we are using it is the so-called distributed and replicated way. So we have, in our case, we have 4 servers, and when a file is uploaded to this cluster, firstly, it can be distributed between servers, so it may go to one or another, but then crucially it will also be replicated to at least one other server. And so again, this means that we've got the throughput, we've got several servers able to provide that file, but we've also got the replication, therefore resilience, that means that if it would take 3 out of the 4 servers to go down before we actually experience any real data loss. So this is pretty much a recap. So the PBS is the block storage. You then use a piece of Linux software, a logical volume manager, that allows you to combine these different ELB blocks, that storage blocks that get assigned to each server, and you can then grow and shrink those. And then Gluster itself layers on a concept of bricks. Each server is just a brick, a storage, a chunk of storage, and it then takes care of things like distributing files across servers and replicating them. All of this, once it's set up, is brilliant because effectively the entire cluster appears to any server that you mount it from. So sorry if I go back here. So all of these servers want to access the file system here on Gluster. With Gluster, it all looks like a single mount point. So you could just, if this has 20 terabytes available on it, distributed across 4 servers, 8 servers, whatever it may be, it doesn't matter. To these machines, it's utterly transparent. It just turns up as an NFS or GlusterFS mount point, and suddenly it's like having a 10 terabyte disk on every single server. So all of this allows us to put the information onto the servers, and helps with the resilience. We've got lots of servers now. It would take quite a lot of them to go down before it disappears. However, there's sort of one other factor to be considered, and that's it's literally the physical location of these servers. If they're all in one room, in one place, in one data center, and that place gets hit by an asteroid or a bomb, or someone cuts the network cable or whatever, then no amount of spreading over servers is going to help you. It's still going to disappear from the outside world. So Amazon, again, can help with this. They have data centers in 5, I think it's now 6 different regions of the world. They've recently added another European one in Frankfurt, but the current one we're using is in Dublin, Ireland. And so the general idea is to pick a data center and to host in one place, generally closest to where the bulk of your web traffic is going to come from. And then for resilience, each region has different availability zones, and a different availability zone means literally another data center. Now they're connected via extremely fast network links, so in network terms, they're very close, and it's the latency is very low. However, geographically, they're guaranteed to be on different sites, and they do things like consider even different floodplains and things like that. They've got exacting requirements about making sure that it's fairly unlikely that 2 availability zones will go down at the same time. So what we have there is effectively you make sure that all of your servers are split. So there's new brown outline here, availability zone 1, availability zone 2, and this again means that you could literally knock out an entire Amazon data center and you would still have a functioning system. So just before I come to the last bit, just saying I kind of lied in that what I've been talking about so far is a standard Drupal setup. In the case of the Qatar Digital Library, we actually added some more sort of non-Drupal components there. So first of all, we use a system called IIPImage to actually render the zoomable images on the fly from the high resolution master file. So effectively these are a whole new set of web application servers, and these are the ones that really most of the time talk to that the GlusterFS storage network. We do store the Drupal assets there, but they're a small fraction of the overall data. The other thing we've got in the mix is Apache Solr, which we use to allow very fast searching of all of this data, and also to store a lot of the structured archive information. So essentially in network terms, this is a bit like another set of Drupal servers. They are front-end web application servers that actually serve HTTP requests to the public, and this is a bit like another MySQL database cluster in that it's a back-end data store that Drupal has to communicate with. So what we have there, adding those to the diagram, we've got two sets of web application servers all going to the public, and we've got another bit of back-end data storage, which is we use Solr Cloud, and again, similar to GlusterFS, we've got a cluster of these things split across availability zones, and Solr Cloud in fact deals with its own replication across servers. So we've got a slightly more complicated setup. And the reason I mention this is that there's things you can do to enhance the security of your overall systems on Amazon. So the first of these is that they have a concept of virtual private cloud, a bit like virtual private network. You can define your own network architecture. There's security groups, which are effectively firewall rules that you can apply to individual groups of servers. And then there's also ways to restrict who and what roles can use the Amazon account, so who can spin up new servers, who can access billing information, and so on. So what this means is the final setup, I promise this is the last network slide you'll see, has all of these things that are public facing in a public subnet within the virtual private cloud, and all these things that are back-end only in a private subnet. And I haven't been able to draw the lines on because that would get really complicated. But essentially all these things, it's a bit like the normal network, you've got a sort of devirtualized zone. These things can talk to those things, but not to the outside world. And these things talk to the outside world and to those things. And the final thing, the little wrinkle here, is that if you set up a private subnet on a virtual cloud, you need a NAT gateway or equally sort of called a bastion host, which means that this allows these machines to access the wider internet if they need to, and also crucially us if we need to come and administer these. We go through one host to get to these because all of this is locked off. So it's a way to enhance the security of your network architecture. So it's pretty complicated by now. We've gone from a single Drupal machine to, I think we're running 21 instances there once we sort of factor in the staging and development environments as well. And what you want to do is manage that complexity. So if you're dealing with, well, I would say actually if you're dealing with any servers, even one, then automate all your provisioning. And there was, so we use Ansible, other provisioning systems are available. I believe there's a talk about Ansible in particular happening tomorrow. We think it's great. What it means is that you can push out a known configuration to your servers, and if you need to push it out to 10 servers, it's no different to pushing out to one server. So again, we can replicate, we know exactly what's going on every server. Here's a little fragment from a Ansible file configured in YAML. It does things like you can specify the packages, the apt packages you want installed. You can start services, make sure that Apache is running. You can install things via pair and so on and so forth. And again, you get a known configuration every server. And all of this is an idea. I've got a link to a sort of discussion about this. The idea is that your servers, especially when you're running lots of them, they should be like cattle. If there's a problem, you just down one and you recreate it. You don't care, you don't troubleshoot, you just go fine, get rid of it, bang out a new one. And tools like Ansible help you to do that very, very easily. The idea of sort of lovingly hand creating or SSHing in and configuring packages and so on, I would say this should not happen anymore. So the other thing we need to do is push out updates. We're changing the Drupal code base all the time. So we use various Drupal tools to do this. We use Drush Master and we use that to control which modules are enabled on which servers and which environments. So we use that to group together and make sure that things like, the develop module might be installed on our development environment, but it definitely isn't going to get pushed out to live. We use features to capture configuration, strong arm to capture variable values, and effectively this then means that all of your configuration, whether it's what packages are stored on the server, right down to what's the value of a specific Drupal variable, is captured in code, in source control, and you know absolutely, definitely exactly what you've got on each server. There's no going in and manually changing things. All deployments are absolutely repeatable. So those are the Drupal tools we use to make sure that happens. The other thing we do is the actual deployment itself. So when we push out, we do a new deployment, this time it's to a cluster of servers instead of one. So again, you can't just sort of FTP over some files and hope it's all okay. It needs to be a bit more involved than that. But you could use Ansible for this. We actually use Fabric, which is sort of a Python-based system for managing deployments and running remote commands. And here's a little snippet of it. So effectively, you can do, so here, we're running Drush commands on the server. We'll do things like put it into maintenance mode, update, push out the new source code to all different servers, then run things like cache clear and archive dump, and then take it out of maintenance mode. There's a tip, it says that Fabric has a runs once decorator, because again, once you're dealing with a cluster, what you'll find is certain actions apply to the whole cluster, like I want some new source code, but other actions only need to be run on one particular server or happen once, such as sort of a Drush cache clear. Once you've got all this up and running, you need to test it all. So load testing, the JMeter, Java-based local testing tool that we've used, very powerful and capable, or online services such as Blitz.io. And then you want to do some performance tuning. So things like Apache Benchmark will give you a very quick indicator of the actual page render time you're looking at. Things like YSlow, Google PageSpeed will look at sort of wider issues or client-side issues like how many requests are being made, the size of all associated image and CSS files and so on. XXProf is great if you find yourself with a slow render time to actually identify those performance bottlenecks and go and fix them. And then just generally, so some things that we found was very useful is make sure that you fix the warning and notice messages as well, so that you're not cluttering up logs. On the subject of logging, on sort of high volume sites, you don't want to use database logging at all, because it will just really slow things down. So we moved that into the syslog. Have an opcode cache like Zend Optimizer, and then front-end techniques about the minification, and then also consider lazy loading of data that you won't need immediately. And I think Richard from IIPImage was saying that's again something they use a lot on the Lush e-commerce site. And so, for example, here, going back to this slide about the OCR transcript, this with all the positional information. It involves hundreds of kilobytes of XML that includes, XY coordinates for every single character on that screen and so on. Again, that was adding to a huge amount to sort of the page weight and render time, and by moving that out so that it only happens via Ajax, then it helps speed up this particular page quite a lot. The biggest thing you can do to help yourself though is add caching. So Varnish, caching reverse proxy, effectively means that once you only need to render the page once in Drupal, it then gets cached in memory by Varnish, which will serve it way, way faster than Drupal ever could. And so this has a twin advantage of really speeding up performance for site visitors and also really reducing load on your Drupal site, because again, if you've got a cluster of 8 machines and they're all receiving requests and they're talking to one central database, you can start to get bottlenecks there as well. So Varnish is fantastic and use it. Other things that are useful that we can actually use on this project, but in general, having a central memcached or Redis server for the cache tables. And in fact, again, Amazon provides their own implementation of memcached, Elasticache, so you can use their service for that as well. Considering a CDN for sort of the front-end assets, and again, Amazon has one. And so you do all that, you add your caching, rerun your load test, and then you should be able to sort of confidently say, okay, for X number of concurrent users, we can return pages within a certain response time, and then you're happy. The last thing you want to consider about the system is dealing with spikes in traffic. So if you suddenly get unexpectedly high load, equally if you get unexpectedly low load, what can you do about it? And the short answer is scale it. So you can, if there's, you know it's going to be on the front page of the BBC website or something, you can scale up in advance. You can spin up another 4 front-end servers, and you can have a huge number of Drupal servers ready to handle requests in advance. And the auto-scaling rules you can set in, you can also have auto-scaling so that you can tell Amazon to effectively say if traffic is high or if CPU threshold goes above a certain point, then fire up another server that's identical to the 3 that are already there. And the way that works is that any server, you can take a snapshot of it as an Amazon machine image, and this snapshot then it's a snapshot of the entire machine. You can then say fire up new machines based on this snapshot. And so again, this makes it very easy to add identical cluster members, and we have that in place for the image servers, where effectively IIPImage is a standard piece of software. It just sits there, and we've got rules to scale it up or scale it down according to load, and this is where your cat will come back in. It gets slightly trickier with the Drupal servers, because again, they will not remain constant. The reason they change is because we change and we create new code, we do deployments, and so effectively every time you do a deployment, you risk being out of sync. Any AMI you've got is going to be stale. We use an interim solution for that. Is just every time we do a deployment, we manually create an AMI, and then we can get the auto-scaling rules to use that AMI to push out more servers. And this is effectively a problem with sort of Fabric pushes out to servers. It needs to know which servers are available in advance. In the longer term, we plan to automate this as well, so that Fabric can use the AWS API to query how many servers are in the load balancer at the moment, make sure all of those get the latest code, and then also probably go and create a snapshot and reconfigure the load balancer to say it will use the latest one. So all this can be automated, we just haven't got around to it. So other things you need to consider, and sort of for completeness, because we're using Amazon services to help us with this, is backing up your data. Effectively, as I mentioned, there are AMIs. You can if you snapshot a whole machine, that's effectively a backup. It's in a way it's way too much backup, because it gets everything, whereas you probably only care about a small amount that is the data that's changing. You can also do snapshots of the actual ELB volumes themselves, and again, if you've got a simple setup, that's a sort of legitimate and easy way to make sure that you've always got, say, a copy of your Drupal files. Is you snapshot that one volume every night. In our case, because our files are sort of smeared across a cluster, then we can't use that technique because you can't. There's multiple ELB volumes involved, and it would be tricky to recreate them. So in that case we use S3, which is a REST-based storage system that's guaranteed to be extremely available. They promise not to lose your data, and so we've got cron jobs that will synchronize stuff over to S3 every night. A more recently introduced thing they've got is Glacier, which is designed for long-term storage. So if you don't think you're going to need it back very quickly, and in fact they say there's a 4-hour lead time to get any of your data back, but equally they promise to keep it very safe, then you can use Glacier, and there's a fantastic integration between the two. You can literally tick a box on an S3 bucket and say, okay, move this to Glacier after 2 weeks or something like that. And so it is very useful. Effectively, we use snapshots with the RDS service to provide a nightly backup. For all other assets that are on the files, we use S3. You can also have S3, again, tick box option to enable versioning. So again, you can have a sort of retention policy. So you can keep files for a certain time and then effectively rotate them, get rid of them, or after a time move them to Glacier, and then after a certain time also delete them from Glacier. So it makes Amazon services makes it very easy to create this sort of backup of your data, including versions. The other thing you need to do is monitor all of this. So Amazon comes with something called CloudWatch that provides you various metrics about your servers and network and what's going on. You can configure alerts based on all of these metrics. So here's some of them. We can get things like, okay, if there's Drupal errors, a certain one Drupal 500 error, we would probably send an email to sort of low priority address to just check that. If there's more than 5 of these in 5 minutes or something, chances are there's something else going on, and in that case it might go to a sort of more high priority email address where somebody will actually action it. You can do all sorts of things. Is there too much CPU on one machine? Or equally, is there 0 CPU? If suddenly all your servers are at 0 CPU, that's probably also an indicator that something's wrong. So configure alerts. You can do that via CloudWatch. The other thing we do is sort of log analysis. If you've got a cluster of servers, you've got a problem in that the logs are not centralized. So the load balancer can centralize those logs, but equally if you want the detailed information from the Apache logs or the system logs for all of those machines, you can no longer rely on sort of the simple way. If you've got one machine of just, well, let's SSH in and have a look at these things and tail them or whatever. You need something that will aggregate it, and also in a way, while it's there, if it can do other tricks as well, then so much the better. So we've started using a service called Sumo Logic, which will aggregate any logs you like. You can throw loads of logs at it. It comes in with some built-in things like this elastic load balancer dashboard that sort of shows you where the traffic's coming from and total requests and data volume and things like that. But you can also sort of configure it so you can quickly dig down and find out if there was a traffic spike at a certain time, if there was a cluster of 500 server errors, try and find out what was going on at that time. So something like that, Sumo Logic or Loggly or similar, is very useful. And then the very final thing is, think about what needs to happen. Or if alerts get triggered, as I say, if they're ones that are really serious, like the site is not responding, then you need someone to be able to act on it. We use Ops Genie for that, to actually push out sort of SMS messages to people, and you can do things like set schedules of who's on call, who isn't, things like that. So wrapping up some of the gotchas that we found. GlusterFS, we initially, and for the sake of sort of simplifying the whole architecture, thought, brilliant, we'll store our PHP files on Gluster as well. We'll have, again, one single source of truth, and this will help with deployments, because we put the files in one place. We don't have to worry about the cluster. It could be as big or small as it likes. This turned out to be a really bad idea. The reason is, Gluster is fantastic at data integrity. It's not so good at serving small files very, very quickly. And it turns out that every time a request comes in and goes through Apache to PHP, PHP stats the file, it checks that it hasn't actually changed. And this, on most file systems and operating systems, is a very unexpensive command. It just says, yes, nothing's changed. On Gluster, it turns out it goes and it checks all the other cluster members just to make sure that no one else has put a more recent version of the file there, and then it will come back and go, yeah, it hasn't changed, And once we found this during load testing, that suddenly all the CPU on all the Gluster servers was going way up, the Drupal server was getting bogged down, and so on and so forth. So, and we hoped that opcode caching might actually solve this, but it doesn't. So basically, don't put your PHP files on Gluster, tempting though it may seem. The other thing is the custom Drupal cache. We use Drupal cache to cache the rendered output of all of these hundreds of thousands of archive pages. This is where it can become a problem. So under development, we're regularly clearing the cache, but we also have very few users looking at very few pages. It goes live, suddenly there's users looking at hundreds of thousands of pages. Each one of those can very quickly build up your cache tables, and you can get this sort of uncontrolled growth and problems with then managing that and running out of disk space on the RDS, basically. A few tips. If you have certain servers that you really don't want to go down, such as, say, your Drupal ones, then you can just put an option on them, say, to use termination protection. That means that you can't accidentally, through the console, just go shut down these servers, because Amazon makes it very, very easy to fire up and conversely destroy these virtual servers. And so some things you want to make sure that no one by accident is just going to get rid of that. Enable Elastic Load Balancer login. There's sort of some vaguely hidden options there to say push the logs all to an individual S3 bucket. And then once you've got those logs, again, that's really useful for traffic analysis, because there's things like Google Analytics. They're great for knowing about what human visitors are doing. If you're being subjected to a bot attack or anything, the only place you can get those metrics is from the load balancer itself, and that's what and to do that you need to be able to log it and analyze it rather than just throw that information away. A little tip here: so the Elastic Load Balancer, if it has a concept of health check, it will check all of the hosts behind it to make sure that they are serving files, and if they aren't, it will kick them out of the load balancer. Now, the problem comes is if you're doing something like putting the site into maintenance mode, the standard Drupal down for maintenance page will return a 503 error code or something like that, even though it's giving them a very nice sort of friendly page saying we're down for maintenance. It still has that error code. The load balancer will look at that and go, you're not fit for service, I'm kicking out the load balancer. Oh, I'll kick out all the other ones as well because they're all at it, and then you're left with basically a load balancer that has nothing behind it and certainly doesn't put anything friendly up there. You get just a white screen and wonder what's going on. The maintenance 200 module is a very simple module that just says change that status code to 200, so at least then the load balance and Varnish and so on will see that as, okay, I can serve this page, people can see a down for maintenance message. You can also, I would also advise going a bit further than that and actually go and create a sort of down for maintenance server that just has a static page that says we are down for maintenance. The reason for this is that if you do encounter problems like, that was an example where suddenly everything gets kicked out the load balancer. If you've got a server just ready, or an AMI just ready and waiting to say, okay, put this one into the load balancer instead, you can at least get something up there to show site visitors while you then go and troubleshoot the rest of the problems. And equally, if there were catastrophic problems with the database server or the GlusterFS file system, whatever, having this server on hand means that you can at least, you're not airing your dirty laundry in public. The visitors just see that you're trying to do this deliberately, instead of seeing a half-broken site with maybe no Solr search results or broken images or so forth. So in conclusion, we ended up with a fairly complicated system, 21 EC2 instances, 6 different load balancers, 67 ELB volumes. It was a lot of work to set this up, but like I say, by using the automation tools like Ansible, Fabric, Drush, so on, it means that it's very quick to alter this. So we have a very known, very stable system, and we can very quickly push out changes to anything from, you know, a tweak to the PHP code down to different packages on the Linux servers and so on. And yes, it's coped with the, as I say, the key requirements of scalability, throughput, and resilience. The day we launched, there's quite a lot of press coverage. We had, you know, 21,000 sessions and 350 concurrent users according to Google Analytics, and I think it was running at about 20% CPU on a cluster of 4 Drupal servers. So there we go. I won't expect you to memorise this. I'll upload this to SlideShare this evening. I haven't been able to get onto the network yet, but there's some useful and interesting articles here. Someone else's approach to using autoscaling with Drupal. AWS tips I wish I'd known before I started is a great read. And then also again, banging on about this servers being pets or cattle. There's a little write-up of that there. A final quick plug, I work for CogApp, I'm the head of web development there. We're always keen on finding new, bright, interesting people to come work for us. In particular, we're looking for front-end specialists and graduate developers at the moment, so if you're interested, feel free to talk to me, have a look online, and that's it. So I'll be around for the next hour or so. If you want to talk to me, or if you have questions now, please let me know. Yes?
I appreciate you probably can't talk exact figures, but how much?
It ain't cheap. So a few $1,000s a month is what you'd be looking at for a setup like this. So
under 5 or under 10?
Under 5. Yeah. So it's you know, Amazon, they've got in many ways a very transparent pricing structure, and there is a sort of cost calculator that you can use. So it's quite easy to get a general idea of, okay, if I did have 4 M3 large Drupal instances talking to a cluster of 2 M3 medium RDS things, and you know, you can quickly work out in advance roughly how much you're looking at. So yeah, I would say it depends a lot on the circumstance. There are also a lot of charges that are kind of very hard to know in advance, like, you know, you get for RDS, you get charged for sort of running the service, but also per 1,000 or million database transactions, and it's kind of, you know, you won't know that really till you're up and running. Equally, things like you get charged for the traffic, although I found that has been, you know, that will again depend on the setup, how big or small that will be. But
so that under 5K figure has been proven since you've launched.
Yes. Yeah. So it's, you know, yes, it's not cheap, but in a way, but you're still getting, there's an awful lot you are getting for that. Yeah. And again, the key advantage you do have is that it's very easy to tune that. You know, if it turns out that actually, yeah, there's way less traffic than you expect, you can suddenly, you know, you can reduce the overall infrastructure quite quickly. Again, depending on, you know, I think the problem with our system is we have several different components. You know, we've got Solr, Gluster, database, Drupal, IIPImage. Each of those can only kind of shrink so much. And then also, like say, you know, we have a sort of faithful staging environment as well, in that, you know, we have a cluster on that going on, and we have a dev environment also on Amazon, so we're shoving in extra stuff there as well. Yes?
How quick are your deploy times usually to go out all clusters?
So our deployments are it's about 15 minutes to half an hour downtime each time. We're looking at trying to improve that. A lot of it is the sort of enabling and disabling of modules, and I think we could probably do better with that, because it's at the moment it's sort of, I think it disables everything, then enables one by one.
To your dev cluster as well at the time, or is it quicker to the dev cluster?
No, it's about the same. So yeah, I think the key bottleneck there is actually doing the Drush commands. It can also be, as I mentioned, the cache, depending on how much cache size we're using, that can also take a significant amount of time. And again, we're looking at sort of ways to reduce that. Yeah.
Your concurrent users, were they logged in?
No. So this is, yeah, I mean, this is a very important caveat in that all of our site, it's anonymous access. So we have the luxury of being able to, you know, stick almost everything in Varnish, and we have very little requirement for sort of non-cache traffic or anything.
Did you, do you think you could have done something similar with Acquia Cloud?
Yes, absolutely. So Acquia effectively runs, as I understand it, something fairly similar. You know, they have a central Varnish thing, and then you can get, you either have single, large, you know, or varying size EC2 instances running your site, or you can also get a cluster of those as well.
Does it make a difference, price? This is a lot cheaper, right?
Acquia Cloud, I don't know. I mean, you'd have to check. Effectively, I think that it must be more expensive because effectively they have to make some money somewhere. So they you know, at the end of the day, they are renting EC2 servers on your behalf and RDS instances on your behalf. So they have to provide more money than that. You know, charge more than that. At the same time, though, they provide a very valuable service in that they manage all of that for you as well. So, you know, what we have here is sort of the opposite extreme, where we have to manage all of this infrastructure. And like I say, you know, we try to use tools that make it easy, but it's still there's a fair amount going on. Acquia gives you the simplicity of just doing that, but at the same time, the flip side is you don't get so much configurability. So, for example, I mean, the basic question: could we run this on Acquia Cloud? The short answer is I'm not sure, because we need to have the cluster of Solr things, the Gluster set up. I'm not sure how much they actually allow you to modify the machines themselves. I don't think we'd be able to, say, mount Gluster and then access that seamlessly through Drupal, for example. Anything else?
You talked a bit about scaling. Sorry. You talked a bit about scaling or auto-scaling the app servers.
Yeah.
What happens with storage? Like, imagine you pick up all the extra high-resolution images you were talking about picking up. Who decides when to add more storage? Is the system doing that itself, or is that someone deciding to add more of those 1 terabyte blocks?
That's a manual operation currently. I mean, I think you probably you could get that sort of on a trigger and do so, but it would be quite a lot more work at the moment. You know, this stuff grows, but it's not like it's going to go huge overnight. What we have is, again, CloudWatch alarms to say if the storage capacity gets to within 80%, then start sending warnings, and at that point we would go and you know, well, semi-manually add more storage. We have Ansible scripts that you would just say, effectively change your configuration value and say, right, I now want 10 1 terabyte ELB volumes rather than 5 or something.
Okay, thank you.
So, do you have a question?
When this customer come to your company, do you expect how much cost will be ended up using Amazon service? Well, it's kind of trial error.
No, so I think, as I said earlier, that you know, you can estimate this stuff in advance, and I mean, we came up with this architecture after having talked to you know, representatives from Amazon, who suggested, you know, things like the multiple availability zone setup and so on, and then effectively, you know, we presented back the options to the client to say, you know, how much do you care? Do you know, we can make this a lot cheaper if you do want it just in one availability zone and so on. There is also almost even more option where you would say, actually, let's have cross-region replication. You know, you could end up with not only a distributed stuff across availability zones, but say, let's ship this over and serve this simultaneously from America and Dublin and so on. So, you know, we effectively asked the client what they wanted. We gave them an estimation of the cost involved, and then they decided. Yes.
Just to follow up on that, the costs, as I understand, are variable depending on the traffic. Obviously.
They are, yes.
How hard of a sell was that to the client? Was the client on board with having estimated costs per month depending on traffic? Or?
Yeah, they were. And at the end of the day, there is nothing you can do about that until you do it. So yeah, they were ballpark figures. And then really, yes, it's only by running a site that you can really get, you know, the true figures out. What that does mean, though, is that in a way, once you've got over that initial hurdle, then you know it's much easier to know what's going on. You can look at metrics over time and then work out, for example, how much are we spending on bandwidth versus backup versus whatever, and maybe then you might tweak your retention policy or something else and save on those costs, or you know it's very easy to switch server types. So you might go, okay, change all these from M3 largest to M3 mediums, and that will save us X amount. Or conversely, we're getting loads of traffic, these things are creaking, let's vertically scale it to a bigger thing. Sorry,
yeah, I can't remember when the last one was, but there's obviously been some quite notable outages with Amazon. Would this setup have protected you against those?
I can't remember what happened in the last one.
Yeah, I haven't really followed it. But,
I think one time the Dublin data centre went down.
Okay, but was that both availability zones or just one?
Yeah, I don't know.
I think it was that. Yeah, I think it might have been the network cable coming out of it, basically.
Yeah. So I would hope in that case, if that was the case, that it would be one data centre goes down. That means one availability zone is down.
Yeah.
Therefore, the answer is yes. It would have coped with it because we've got this parallel infrastructure in the other availability zone. So.
Just going back to the slide on the backup, I understand the database is backed up with the snapshots. Is that correct? Is that something that Amazon do themselves, or is it something that you have to set up to instruct that? Do you use like an API to?
No, they do it. So again, it's another great thing about RDS is I think it's literally a tick box option.
Right.
I think that's.
Would that be the same if you had if you were backing up a snapshot that wasn't attached to the database? That was
No.
No.
So if you're talking about just the a snapshot of a ELB file system, that you can trigger manually, or you can trigger via the API, and so you would have to have some other cron job that would do something like fire up, a program that runs that scripts the API and says take a snapshot of this at midnight. There's no, as far as I know, no sort of tick box option say back me up every night. Whereas with the RDS backups, which ultimately I think are exactly the same, it's doing a snapshot of the file system, that is something that you just tick.
Okay, thanks.
So,
you said one of your gotchas was the Drupal caching. Do you just turn that off basically?
No,
are you using caching with the Varnish caching as well?
Yeah, yes, absolutely. So I mean, what I would say is that you want sort of cache in depth. Is you don't want to rely on any one mechanism.
Okay.
So yeah, we definitely are using Drupal caching. The problem comes more of just growth of that cache when you're dealing with millions of pages. You can start to just use an awful lot of database space.
So the situation is that the Varnish cache might expire and then it would go to the Drupal cache, and you really do push the database as far away as possible, basically.
Yeah, exactly. So you want you want in a way as many layers of caching as possible, so that if one fails or is circumvented, like the logged in user scenario, that just by default Varnish will just passes the request straight through. That again you're not doing any computationally expensive tasks. So for example, in our case, the archival information we have comes from a sort of horrendously nested great big XML document, and we're using XLT to process it, and none of this comes quickly. So again, with the more caching we can do, the better. Okay, thank you very much. Oh, sorry, go on, one last one.
Question about IOPS and the RDS.
Yes.
How did you go about working out what provision for that? Because it's one of the things that's a little bit confusing sometimes.
You mean the chart? So the IOPS, is that a charging thing, or the what you?
Well, they charge for it, so you have the SSD for
Yeah.
the IOPS.
Mhm.
Because you have to specify that. So there are calculations you can work out values, but you don't know what your load is. You don't necessarily know how to work out values. So it's like it's all kind of finger in the air.
Yeah, so I mean, with that, with RDS, the only real tuning we did was based on load testing. So, where as I said, once you've got your sort of final production infrastructure in place and you've got a cluster of servers, then we would run load testing and go, okay, well, how many concurrent users can we get? And then you can very easily change things like those values or the machine type. So, you know, like move it up to an extra large. And then you want to sort of find the sweet spot between, yes, this is going to cost an absolute fortune and only gives us a slight extra throughput versus, well, that creates a huge difference and only costs another couple of $100 a month or something. Okay, thank you very much.